Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
We are solving previous year's question paper, and in today's lecture we are starting the question paper of May 2019, and this is the first part of that. Okay, so let us move ahead. Now question number 1 has several subsections and we have to attempt any 5 questions. So each sub question is for 4 marks. Okay, so let us read what is the first A part. So it says that explain the working principle of single phase transformer. Now let me tell you that the working principle of single phase transformer has been explained in detail in the chapter 4, which is a single phase transformer chapter. Okay, so please refer to that lecture. B part says derive the formula to convert a star circuit into equivalent delta circuit. Now, if you remember, the same question was there in December 2019, but here this question has been asked for 4 marks and there it was for 10 marks. But please remember, there we converted a star into delta and delta into star. So both the conversions were asked. Here only one conversion is asked. But you can of course refer to the solution of that question in December 2019. Okay. Now let us see question number 1C, that is explain the principle of operation of DC motor. Now DC motor is a part of self-study section in our regular syllabus. So the operation of DC motor has been explained in detail in that self-study section. So you can refer to that. Now the fourth part, which is D part, says that what is a necessary condition for resonance in series circuit and derive the expression for resonant frequency. Well, again, this is a part of unit 2, which is AC circuit, and in AC circuit the subsection was series resonance circuit. So again, this topic has been covered in that lecture. Okay, we have derived the equation for resonance frequency also, and we have discussed the series resonance circuit in detail there. Fine. So these 4 questions have been dealt with in our previous lectures. So let us move to the next part. Now the next part says, that is the E part, calculate the value of R in the circuit. So this is quite a simple circuit, isn't it? Yes. So what we are going to do is, to solve this, let us assume that, see, this is the node, right? So let us assume that this voltage be V. Okay. So if I apply KCL, or by using nodal analysis, what equation can be written? This is V, this is 100. So if you go to this path, it will be V minus 100 upon 10. Okay, so we have taken this into consideration. The second will be this part. So it will be plus V by 14, right? Next, we have to target this part. Now, are we supposed to write V upon R here? Come on. Because here the current is already specified. So see, we are not supposed to write V upon R. Correct? Because nodal equation is what? Nodal analysis is what? We apply KCL only. So if directly current is given, then we will be writing the value of the current directly. Now KCL says that this sum is 0. So we will write 0 here. Now let us solve this. So this becomes V by 10 minus 100 by 10 becomes 10 plus V by 14 plus 3 equal to 0. Correct? So it becomes V by 10 plus V by 14. Now minus 10 plus 3 becomes 7 equal to 0. Now let us take LCM here. So let the LCM be 140. So it will be 14V plus 10V, right? Now this becomes equal to 7. Correct? So the next equation would be 24V is equal to 7 into 140, or V is equal to 7 into 140 upon 24. So now what is the value for V, students? The value of V comes out to be 40.83 volts. Now we are not asked to calculate V. We have to calculate R. So how are we going to calculate R? By using Ohm's law, and it is going to be V by I. So V we have calculated, I was already given. So it becomes 40.83 upon the current was 3, right? So the value of R comes out to be 13.61 ohms. So this is the answer. Okay, so let us move to the next part. Now next part is the F part. Again, as I said earlier, this question is for 4 marks. So it says find the current through 4 ohm resistor using source transformation. Okay. So let us see where is our 4 ohm resistor. So here is our 4 ohm resistor. So what we will be doing is we will not be touching this network. Okay, because if we use source transformation here, then 4 ohm resistor will be disturbed. So what we will be doing is instead we will convert this into its equivalent voltage source, right? So this is 5 ampere, this is 2 ohms. So this is I, this is R. So what is going to be V? V will be IR. So it is 5 into 2, that becomes 10 volts. And then in series with the resistor 2 ohms. Correct? So the next circuit, equivalent circuit would be, here you have 2 ohms. Here we have 10 volts. Okay? And then as usual 6 volts, 2 amperes and 4 ohms. So this is 4, this is 2, this is 6, this is again 2. Now if you carefully look at the voltage polarities of 10 volts and 6 volts, temporarily I'm not considering 2 ohm just to simplify this. Okay, so this is how it is connected. So see, similar polarities have been connected here. So I have already told you that whenever similar polarities are connected, I'm talking about the voltage source, fine. Whenever similar polarities are connected, the effective voltage will be the difference of these two. Fine. And whenever dissimilar polarities are connected together, then we are supposed to add it. Now since here positive and positive terminals are connected, it means the effective voltage by these two voltage sources will be 10 minus 6, which makes it to be 4 volts. Understood? Okay. So now let us modify the circuit here. So this is as it is. Even 2 ohms will remain as it is. The only difference will be this. So this becomes 6 volts. Sorry, 4. It is 4. Yes. So this is 4 volts. Come on, tell me what is going to be the next step now. Again, we have a bit complicated circuit. We have a voltage source and a current source. So what should be the next part? The next part is we will convert this 4 volt voltage source into corresponding current source. Okay, so we will be converting the voltage source into current source. How to do that? Come on, Ohm's law. Current is equal to voltage upon resistor. So now here the next equivalent circuit would be this. Okay, so this becomes 4 upon 2. So that is 2 amperes. And the resistor goes in parallel. So now this is 2 ohms. Then I have again 2 amperes and and 4 ohm resistor is there. Now please pay attention here. Now if you see this current source and this current source, the direction of current source is upward. So what is going to be the rule? Come on, if they are into same direction, they will be added. Fine? Yes. So the next circuit would be, we have a single current source in parallel with a 2 ohm resistor, and our load resistor as of now is 4 ohms. So this is 2 ohms. So 2 amperes plus 2 amperes makes it 4 ampere. Correct? So now this is the reduced network. Now this becomes the total current I. Correct? Now we can simply assume that this current be I1, let this current be I2, and the first current be I1. So now you can apply current division rule. So by current division rule, I can say that I2 is equal to the total current multiplied by the opposite branch upon the total branch resistance. Okay? So what is the total current? 4 into 2 upon 6. Fine? So the current through 4 ohm resistance is 4 by 3 amperes. This is my answer. Of course, you can divide 4 by 3 and you can also write the final value of current. So what is going to be the current through 4 ohm? If I cut this, 3. So it becomes 1.33 amperes. So even this can be the answer. Fine? Okay. So let us go to the next numerical. Now the next numerical says determine the current through 8 ohm resistor using superposition theorem. So what do we do in superposition theorem? Here two sources are given. One is the 4 volt source and another is the 6 volt source. So for superposition theorem, one source at a time is considered and the current is found out. Now in the next part, another source is considered, again the current is calculated, and the total current will be the sum of these individual currents, but we have to take the direction into account. Okay. So what should be the very first step? This question has been asked for 8 marks. Fine. So what should be the first step? We will be considering one source at a time. So first let us consider 4 volts source acting alone. Another source will be short circuited or it will be replaced by its internal resistance. Internal resistance is not given, so simply we are going to short circuit it. Now what we have done is, we have considered these nodes and these nodes are being named by V1 and V2. So we will be using nodal analysis. Fine. So let us write the nodal analysis or KCL equation for first node. So if you pay attention, the first equation is this path, right? So it is V1 minus 4 upon 5, correct? The second is this path. So it is V1 minus V2 upon 10. And third is this path. So it is V1 upon 15, which becomes equal to 0. Okay? So when we solve this equation, we get 11 by 30 V1 minus V2 upon 10 equal to 4 by 5. Okay. Again, we will be applying the nodal equation. Yes. So we will be applying the nodal equation at node number 2. So now it becomes V2 minus V1 upon 10. Similarly, next is V2 upon 8. And then of course V2 upon 12, because here we do not have anything, right? So it becomes V2 by 12, which becomes equal to 0. So again, when we solve this equation, we get minus V1 upon 10 plus 37 upon 120 V2 equal to 0. Okay. So when we solve these two equations, equation 1 and equation 2, we get the value of V1 and V2. Okay, these are the simultaneous equations. We can solve these equations. So the value of V1 comes out to be 2.4 volts and the value of V2 comes out to be 0.776 volts. Okay. Now what is going to be the current through 8 ohms in this equation? It becomes V2 upon 8. Okay. Fine. So we will be putting the value and we will be getting the answer. Okay. So the current through 8 ohms comes out to be 0.097 amperes. Please remember that this is a positive value. Okay. So whichever direction we assumed, the current actually is flowing in that direction only. Fine. Okay. So next we will be considering the second source, which is the 6 volt source. Now we have short circuited the first source, which was 4 volts voltage source. Again we have assumed the node voltages and then we will be writing the KCL equation by applying nodal analysis. Okay, but here just to differentiate amongst various voltages, instead of 1 and 2 we have assumed node to be 3 and 4. So let us write the nodal equation. So now you are aware how to write this equation. So first V3 upon 5, then V3 minus V4 upon 10 and then V3 upon 15 is equal to 0. Okay. So this is the third equation. Next we will be applying the next equation. Yes. So here it will be V4 minus V3 upon 10, right? But here now we have 6 volts. So the next will be V4 minus 6 upon 12 and the lastly V4 upon 8 equal to 0. So when we solve this, we get this equation. So what is going to be the next step? Again, we got two simultaneous equations, equation 3 and 4. So we will be solving these two equations and we will get the value of V3 and V4. Now in this, what will be the current through 8 ohm resistor? It will be V4 upon 8. Correct? So now we got I2 to be 0.225. It means again it is positive, right? It means that, see, here we said it is moving in this direction, right? So actually it means what? That here also it is moving in downward direction and here also it is moving in the downward direction only. So what is going to be the total current? Total current will be the sum of these two currents, and since these two currents are, both the currents are positive, so we can simply add them, right? So it will be the sum of these two currents, that is 0.097 plus 0.225. So the answer comes out to be 0.322 amperes. This is the current or answer. Okay. If one of the currents was negative, then we would have considered that negative sign also. Well, that is not the case here. I'm just telling you that that is a procedure. Okay. So with this question, we are stopping today's class. We shall be meeting in the next class with few more questions. Thank you so much.